Hello, Uggies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. The object of this video is this little device right here. You'll recognize it as a choke balun, where the cable comes in, wraps several times around a ferrite, and comes back out. This is designed to go into, it's assuming you've got an SO239 at your antenna's feed point. And it will screw in there, and then you screw your coax in down here. Now when we say choke balun, that means the cable coming here is unbalanced, okay? And you can put a balanced antenna in on this end. Now if you get some feed through from the antenna back down the coax, it comes into the inductance created by the balun. Now there are a number of different ways of doing this. This is from GOOZEEZOO. GOOZEEZOO is a Chinese manufacturer that makes open source kinds of things and provides them quite inexpensively. Like I just got this Nano VNA, the large one, from Teagan. We'll take a look at that in another video. But this right here is going to be tested on this. Now another way of checking that is this device right here, which is an old MFJ 915 choke isolator, 1.8 to 30 megahertz. What it has is you've got a down, back up, and a down of the coax, and it's completely filled with those little beads, the beads that you put around these things to help keep the common mode currents off. We're going to take a look at this too. And then another one that we have right here is your old classic standby for choke balun. This is the old classic for a choke balun, is to just take several turns of coax and wrap them together. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 turns, okay? Right there on that. Now, let's take a look at this and see how this performs. Okay, now there are two curves here. Notice we're using both ports of the Nano VNA. It calls it port 1 and port 2. This is S11, this is S12. Now, the signal comes out here. Now, if it comes back, that's a representation of the loss in the signal from which it can compute the SWR. But when it comes back in here into this port right here, it now tells you, compared to the frequency, what is going through the cable. This device right here, which was covered in a recent QST article, right here actually inverts it. It takes the inside of the coax here and puts it on the outside of the coax here. So now whatever inductance we find with this, we find it's on the outside here and then goes back on the inside. So this will tell you how much impedance, in this case inductive impedance, they're all inductive, is put in here to see the degree of isolation. So on the chart, what we see here is starting at on the 80, 60, 40 bands, there's very little kicked back. So the SWR kind of degrades as you go up here because there's a resonance phenomenon going on here. That means that the inductance from this is also reacting with the capacitance, because when you put two together, the shield in this one and the shield in this one, there is a capacitance between them. And there is a natural resonant point, which appears to be right about here. So I would say this works on 80, 60, 40, 10 meters. This is 10 meters right here. It's a very thin line. And then there is 20 meters right here. And then when you get up to 17, 15, and 10, the thing certainly misbehaves a little bit. So I wouldn't recommend this many turns for the higher frequencies. I'd go with fewer turns. Okay? Now, this right through here is the throughput. This is what comes all the way back. So when we're on 80 meters, this thing actually isolates to like 50 dB. This is how much the coax cable coiled balun will reduce the impedance that's coming back. It reduces the impedance here through 80 meters, about minus 50 one end, about minus 40 the other. That's excellent. You actually need about 25. But note here on 60 and on 40, it's only reducing it by about 18 dB. And when you get up into here, it's hardly reducing it at all. But you're getting that resonance phenomenon. So I would use this thing. I told you the number of turns that I had in here. If you want to move this curve up, put fewer turns in. Okay, this is great for 80 and 60, but not so good on up. You'd have to have fewer turns. All right, that would give you less capacitance, less inductance, but it would move this curve this way. All right, now with the GOOZEEZOO, what we're going to do, this screws into here, but this wants to go onto the coax cable. Okay, so I need an adapter here, and I'm going to put that adapter in. Okay, and we've got our little nano VNA there, and this is what we get out of it. This is supposed to be for 3 to 30 megahertz. Let's see how well we do. Up here, from an SWR point of view, it hardly gets in the way at all. Okay? We're not getting a lot of capacitance between the shields on this thing, so it's doing okay from an SWR point of view. This is S11 back into itself. Now this is S11 coming into S12, so it goes through the whole thing. Let's see, it starts here at S11, goes into here. Now this thing flips it, so what's inside the coax here is on the outside here, and then we go back to the inside here. And what we're doing is we are measuring the outside ability to turn a balanced circuit, like an antenna, into an unbalanced circuit. This actually does pretty well. Now at 80 it comes up a little bit short. It's 25 dB down. Well, doggone, 25 dB down is actually a lot. This is reducing the RF, trying to get down the outside of the cable and get down to your transceiver. And we see that it gets steadily better over 30 at 60 and 40. Here it really shines on 20 meters. There's a real thin right here for 30 meters. And then it comes down 15 meters. It's actually excellent. 40 dB down is fantastic. And then it kind of starts to flirt with resonance here. There's enough capacitance here, we start to get some phenomena. But look still at what happens. So what this means is that the common mode signal will be brought way down. Okay? This is an excellent result. And I have to say that the GOOZEEZOO deserves a thought if you're putting up a dipole antenna and want a simple little choke balun here that will really help. Now this right here is an MFJ 915. It says an RF isolator. This is actually a choke balun. This will go up. This is $60 in the old. Of course, MFJ is gone now and can't give us what we want anymore, which is too bad. Okay, let's take a look at the chart for it. You've got an SWR problem right off the bat. Your signal is going down to about 7 or 8 dB, which is about an S unit down on the SWR, so the SWR would be worse. Now we look at the log mag curve. This is going through the balun, and we find something interesting here. It does really well. Again, about 25 dB down to 22 dB. That's great for the 80 meter, 60 meter, 40 meter, 30 meter, 20 meter bands. And then it starts to behave weirdly. We've got some resonance going on here. There are different frequencies. This right here still makes it okay for 17 meters. But when you get up here above that in frequency, there is, since these things are packed in here pretty tightly, there's some capacitance between the windings, and that's reducing the effectiveness, because remember, we're getting our inductance, which gives us our inductive reactance from the ferrite beads. But we're also getting, and that gives us this, but there's also a capacitive effect in here too. And remember, capacitance is opposite of inductance, okay? Capacitive reactance is actually subtracted from an inductive reactance in this case. And it's not so good, but it's okay. I mean, it can help. So if you are like putting up an antenna, now the instructions say to put this right before it goes into the radio. I would say put it up at the antenna. It's strong enough, plenty strong enough. It's made of plastic pipe. These PL239s are actually, the base of them is inside this, so any weight pulling this way, it's pretty strong, okay? So this works okay on the lower bands. In some ways, it's like the coiling of the coax. You put several coils, it'll help you down here. You reduce the number of coils, it'll help you up here. So what we've done in this video is taken a look at 3 choke balance. The one from GOOZEEZOO seems to me to work the best, okay? It covers more of the band. You can use this from 80 meters all the way up through 10 meters, and it will do a good job for you. Now, I would note that these connectors are not waterproof, and neither is this, and I had to put an adapter on there for that. These are not waterproof, hence you will want to wrap some good coaxial tape around these when you put your antenna up. And this end goes right into the SO239 on the antenna, and then your PL259 from your coax goes right here, so it goes right at the antenna. Very nicely done. Now, let's see how much these things cost. We went looking on Amazon. It's not on Amazon right now, although there are a fair number of GOOZEEZOO products. Now, this particular one shows up on the GOOZEEZOO website, and if you look there, it says it's currently unavailable. But I suspect if that means it's popular, or if it's about to be introduced, the price given is $30. So that's not too bad, and it would be shipped from an Amazon warehouse here in the United States, so you don't have to worry about whatever tariffs are left. I'm not sure there are any, but there will probably be more. And you can get this thing and use it. Now, as it turns out, the GOOZEEZOO, which performed the best for $30, this right here is what, 12, and this is about a foot in diameter, so we've got about 60, 80 feet in here, and this coax is more than $1 a foot, okay? So that's twice as expensive as this. And then if you take the MFJ one, which isn't for sale any longer, but this sold several years ago for $60. Okay, so this is not only the best, but the least expensive. So if you can't find one like this, you can always make one. And the instructions for that are all over the internet, and you can look in the antenna book too. So there you have it. That was a look specifically at this, and we compared it with 2 other common choke baluns. This one that has all the beads, ferrite beads, and the one with all the coax, which is an extremely common way of doing it. But actually, you coil that much coax up, at $1 a foot, it starts to get kind of expensive. So there you have it. And until we next meet, 73.